Today's video, I am going to focus on significant figures of a numbers obtained by mathematical operations such as addition, subtraction, multiplication and division. First, significant figures with multiplications. 8.65 times 2.053. Give your result with an appropriate number of significant figures. For that, first we do calculation. 8.65 times 2.053, you will get the result 17.75845. Here the answer have more digits. Now, how should we round this answer to the appropriate number of significant figures? We need to determine the least number of significant figures in the first two numbers. The first number 8.65 has 3 significant figures, and the second number 2.053 has 4 significant figures. Here 8.65 has lowest number of significant figures, which is 3. That means we need to round this result 17.75845 to 3 significant figure. I explained significant figures and rounding numbers clearly in my last video. If you have any doubts, please watch the video and I provided the link in the description box below. Let's recall the rules for rounding off to the correct number of significant figures. Count from left to right. 1, 2, 3. So the number 7, this is the number we have to round up or down. We can call last digit. To figure out, we have to look at the next number, which is 5 here. We can call decider. Here our decider is more than 4. So round up the number 7. When you round up, you will get 17.8. The answer should have the same number of significant figures as the one with the fewest significant figures. Another example, 38.65 times 105.93. After doing calculation, you will get 4094.1945. Check the lowest number of significant figures in the first two numbers. 38.65 has 4 significant figures. 105.93 has 5 significant figures. Here 38.65 is the lowest significant figure, which is 4. 4094.1945 you have to round up to 4 significant figure. For that you have to count from left to right. So after counting 1, 2, 3, 4. So the number 4, this is the one you have to round up or down. We can call this is last digit. To figure out, you have to look at the next number. The number 1 you can call decider. Here our decider is less than 4. That means you keep the last digit as same. The final result is 4094. Next, significant figures of divisions. 138 divided by 11.9. First we do calculation using calculator. We will get 11.596638. Same like multiplication, here also check the first two number of significant figures. 138 has 3 significant figures and 11.9 has 3 significant figures. So you have to round your result to 3 significant figure. For that you have to count from left to right. So 1, 2, 3. This is a number you have to round up or down. So we can call last digit. So number 5 is the last digit and the number 9 is our decider. In this case our decider is more than 5. So you have to round up the last digit. Final result is 11.6. If you want to catch all the details, make sure watch the video until the end. Next, significant figures in subtraction. Let's take an example. 4.4981 minus 1.26. After doing subtraction, you will get 3.2381. For the first number, 4.4981 has 4 decimal places. 1.26 has 2 decimal places. The answer carries the same number of decimal places as the number with the fewest decimal places. Here 1.26 has lowest decimal place, which is 2. The result, which is 3.2381, round off to 2 decimal places. Observe the decimal places in the number 3.2381. Count it. So 1, 2. So the number 3, this is our last digit. And the next number 8. 8 is our decider. In this case, our decider 8 is more than 5. So you have to round up the last digit. So when you round up, this 3 becomes 4. So the final result is 3.24. Now, here is an interesting question. How do we determine the correct number of significant figures in an addition and subtraction when there is no decimal place? For example, 23 minus 14.6. 23 does not have a decimal place. To solve the problem, first we will learn how to properly read a decimal number. For example, 25673. In this number, 3 is in units place, 7 is in tens place, 6 is in hundreds place, 5 is in thousands place, 2 is in 10,000 place. What about if a number has decimal point, just like 0.256? After point, we can read as 1/10th place, 1/100th place, 1,000th place, like that and so on. Let's come to the original problem. 23 minus 14.6. First you do the calculation. That means subtraction. You will get 8.4. And observe these two numbers of place values. The number 23 stops its significant figure in units column. The second number 14.6 stops its significant figure in 1/10th column. Limit our result to the units column. You can do this by drawing a line. Now see left of the line number, which is 8 here. This is the number you have to round up or down. We can call this is the last digit. You can see the next number, which is 4. This is called decider. In this case, our decider is less than 4 or less. So you keep the last digit as same. It's nearly equal to 8. I will explain another example to make it clear. 420 point plus 3.51. Here 420 ends its significant figure in units column. 3.51 ends its significant figure in 1/100th column. Limit our result, we have to draw a line in units column. Left of the line number 3 is our last digit. 5 is our decider. So 5 is equal to 5. As per the rounding of rules, you have to round up the last digit. So your answer is become 423.51. When you round up, you will get 424. I will explain one more example. 500 plus 1.365. First do addition. 501.365. Now observe the place values. In 500, you have trailing zeros. Trailing zeros without decimal point are not significant. So we should not count these two zeros. So you have to count only non-zero number, which is 5. So 500 has only one significant figure. And the second number 1.365 has 4 significant figure. So you have to round up to the lowest significant figure. Draw the line here. This is the number you have to round up or down. So number 5 is our last digit and the next number 0 is our decider. Here decider is less than 4. So you have to keep the last number, last digit as same. The final result is 500. If you like the content, please subscribe to my channel to get more interesting topics in future. Significant numbers in multi-step calculations. For example, 3.54 times 2.6458 times 7.48764. After doing calculation, you will get the answer 70.130224. Observe the original numbers. In 3.54 has 3 significant figures and 2.6458 has 5 significant figures. 7.48764 has 6 significant figures. You have to round up the lowest significant figure, which is 3.54 has 3 significant figure. You have to round up your result to 3 significant figure. That you have to count from left to right. 1, 2, 3. So the number 1, this is the number you have to round up and down. We can call this is a last digit. The next number 3 is our decider. Here our decider is less than 4. So you have to keep the last digit as same. You will get the answer 70.13 significant figure. Here, do not round off any intermediate result and only do it for the final answer. What do you mean by an intermediate result is, in the example 3.54 times 2.6458, when you calculate this, you will get the answer 9.366132. Do not round off this number to the 3 significant figure. If you do, the answer would be 9.37. And after multiplying it by 7.48764, you will get 70.159186, which after rounding off again gives 70.2 as a final answer. So which is not correct. So keep in mind, do not round off any intermediate result. Only do it for the final answer. Three-step calculations with mixed operations. For example, 4.647 times 2.5149 times open bracket 6.2594 minus 2.34 closed bracket. To follow the correct order, remember the 1 in the parenthesis must be done before the result is multiplied by the other number. That means first we do subtraction. The result is 3.9194. But you should not round up this number. You just keep it as it is. Then do the multiplication. 4.647 times 2.5149, you will get result 11.686740 and again you are multiplying with 3.9134. Finally you will get 45.80500. Now observe the original numbers. 4.647 has 4 significant figure, 2.5149 has 5 significant figure, and 6.2594 has 5 significant figure, 2.34 has 3 significant figure. So the number 2.34 has the least significant figure. So you have to round your result 3 significant figure. 45.80500, when you round off to 3 significant figure, you will get, we can call this is the last digit, and the next number 0 is our decider. In this case decider is less than 4, so you have to keep the last digit as same. So your final answer is 45.8. So next, another example, 2.487 times 3.1629 divided by 4.1926 minus 2.07. After doing calculations, you will get the answer 3.705894. So observe the original numbers. So 2.487 has 4 significant figure, 3.1629 has 5 significant figure, 4.1926 has 5 significant figure, 2.07 has 3 significant figure. 2.07 has least significant figure, which is 3. So your 3.705894, you round off to 3 significant figure. So for that you have to count from left to right. 1, 2, 3. So 0 is our last digit and 5 is our decider. In this case our decider is more than, that is equal to 5. Then you have to round up the last digit. When you round up the 0, you will get 1. So the final result is 3.71. Perform the following calculation and report the answers in the correct number of significant figures. If there is any questions arising from the math problems I shared, don't hesitate to ask. I am here to assist and provide answers to any doubts you may have. Thank you for watching. If you like this content, please subscribe to my channel. Your support helps me continue proceeding more content like this.